Alright, so today's lesson is on scientific notation. So numbers written in scientific notation are written as a number, so any number from 1 to 10 multiplied by 10 raised to a power. So for example, we have the scientific notation 2.3 times 10 raised to the power of 4. Now, large numbers can be converted to scientific notation, and numbers written in scientific notation can be converted to large numbers. So for instance, if we have 5,000, we can convert that to a number written in scientific notation, which would convert to 5.000 times 10 raised to the power of 3. And conversely, if we start with the scientific notation of 5.000 times 10 raised to the power of 3, we can convert that back into a large number, or in other words, a whole number, which is 5,000. So for our first problem, we have the number 515,000. If you want to learn more about place values, check out my lesson, Place Value of a Number Before a Decimal. Before we go through and solve this problem or write this number in scientific notation form, it's important that we remember that this number is a whole number. And when we have whole numbers, we have to remember that there's always a decimal right at the end of the number. So that's why I'm going to write the decimal with the zeros, 3 zeros following. So now that we know where our decimal is, we are going to look at the number and place another decimal between the two first numbers, so between the 5 and the 1. So now what we have to do between our initial decimal point at the end of the number to our last decimal point between the 5 and the 1, we have to count how many spaces there are between those two decimal spots. So now we're going to rewrite the number. So if we rewrite it, we get 5.15. Now you can add the zeros or you don't have to. Either way, you get the same number because 5.15000 is the same as 5.15. So once we have that, we want to multiply that by 10 raised to the power of 5, and we're raising the 10 to the power of 5 because we moved the decimal spot 5 times forward. So our final answer is 5.15 times 10 raised to the power of 5. Now for number 2, we have a number written in scientific notation. We have 8.6 times 10 raised to the power of 3. So now we're going to do the opposite of what we just did. We want to convert this number written in scientific notation to a larger number or a regular whole number. So in order to do that, we are going to start with where our decimal point is, and then we're going to move it to the right 3 times. Now we're moving the decimal point to the right 3 times because the exponent right above the 10 is 3 and it's a positive 3. So starting at the initial decimal point, which is between the 8 and the 6, we're going to move our decimal point 3 times to the right. And that's how we get our number 8,600. And so that decimal ends up being at the end of the 8,600. But again, like I mentioned, every whole number has a decimal point at the end of it. We don't always have to write it. We just always have to remember that it's there. Moving on to number 3, we are back with a large whole number. We have the number 44,689. So for this, I'm going to go ahead and write it in a bigger font, and I'm going to go ahead and add my decimal point to the last spot and my zeros falling behind it, just to remind us that this is a whole number. So after I do that, I'm going to put my decimal in between the first two numbers, which are the two fours. And that indicates where I'm going to move my first decimal point to. So I'm moving the decimal point at the end of the number all the way up in between the 4 and the 4. So if I move my decimal point that many times, that is a total of 4 times. And so when we go to write this number in scientific notation, we're going to write the decimal 4.4689 times 10 raised to the power of 4, because we moved the decimal spot 4 times forward. And so the final answer for this is 4.4689 times 10 raised to the power of 4. Now for the last problem, or not the last problem. For number 4, we once again have a number written in scientific notation. We have 3.6 times 10 raised to the power of 2. So once again, I'm just going to go ahead and write this number a bit larger. Alright, so as you can see here, I highlighted the exponent 2. I'm highlighting that number because that number tells us how many times we're moving the decimal. So the decimal initially starts between the 3 and the 6. And what we want to do is move it to the right 2 times. So if we do that, the decimal ends up all the way past the 6, and we have the number 360. Again, you can write 360.00 or just as 360. It is all ultimately the same thing. Now for number 5, we are back to a large whole number. We have the number 70,532. So once again, I'm going to write that a bit larger in a different color. And again, when we have whole numbers, our decimal place is at the end of that number. If we're reading the number left to right, it's at the end. So our decimal place goes right behind that 2. And we want to move that decimal place in between the first two numbers of this larger number. So we want to move the decimal spot between the 7 and the 0. And so now that we know where we're moving that decimal spot, we're going to count how many spaces it takes to move there. So it takes 4 spaces, which means that when we write this number in scientific notation, our 10 is going to be raised to the power of 4. But also when we move this decimal spot between the 7 and the 0, we get the decimal number 7.0532, and then once again times 10 raised to the power of 4, and that's our answer. 70,532 written in scientific notation is 7.0532 times 10 raised to the power of 4. And for our final one, we have 7.9 times 10 raised to the power of 5. So again, I like to write this out a little larger, but looking at our initial decimal, 7.9, we have our decimal number. Now we want to see what we're doing with the decimal. How many times are we going to have to move this decimal? And we can see that by looking at our exponent. Our exponent is 5, which means we're moving our decimal 5 times and to the right because it is a positive 5. I will be doing a lesson on negative numbers written in scientific notation, and for that we will be moving the decimal place in a different direction, but because these are all positive numbers, we're constantly moving in the positive direction to the right. So when we do that, when we move this decimal that's in between the 7 and the 9 5 times to the right, we end up with a large number. We end up with 790,000. And so that is our final answer.
Wait, before you leave, go ahead and check out these lessons up above. You can watch this lesson, or you can watch that one, or you can watch both. Oh, and while you're at it, please do me a huge favor and subscribe to my YouTube channel. You can do so by clicking out of this video and hitting the subscribe button. Thank you so much. Bye.